Welcome to the Solace webinar. Today, our webinar is with our partner Hazelcast on going global within data memory. Our speakers today, Viktor Gamov of Hazelcast and Mike Hilmen of Solace. Viktor is a senior solutions architect and developer advocate at Hazelcast. He has comprehensive knowledge and expertise in enterprise application architectures, leveraging open source technologies. He's helping companies build low latency, scalable, and highly available distributed systems. He is a co-author of O'Reilly's Enterprise Web Development. Mike Hilmen is a senior solutions architect for Solace. He has over 15 years of experience in messaging middleware space, serving in services, sales, and solution architect roles. He's also helped to drive the deployment of the Solace Train demo, showing the power of open data movement in the IoT space. So today, we're learning about the going global within data memory. Solace and Hazelcast combined to accelerate the processing of global data workloads by providing a distributed, publish-subscribe backbone that enables remarkably fast, efficient cluster synchronization across WANs. This joint solution enables multi-cloud and hybrid cloud replication of Hazelcast clusters for worldwide operations with enterprise-grade reliability, massive WAN scale-out, and low latency cluster replications. During this webinar, we're going to learn about some example applications of this that synchronize real-time position books and mobile carriers that use in-memory operational data to provide a fast and seamless end-user experience. Remember, you can ask your questions during the webinar, and we will try to get to them at the end. So with that, welcome Mike and Viktor, and let me turn it over to our speakers.
Thanks, Dave.
Thanks,
Good morning.
Dave. Good morning. Hi, this is Mike. I'd like to start with who's Solace, right? Who are we, and what does Solace do? Solace is all about moving data, right? Solace has more messaging experts focused on creating and delivering innovative data movement solutions than anyone else in the world. Solace has built a profitable, rapidly growing business by meeting the needs of companies both large and small, and counts many of the world's best companies as customers. Solace has been around for over 10 years. Currently, there's over 200 people and 15 offices worldwide. We have 24/7 follow-the-sun support and been the recipient of many industry awards, right? Many of them more than once annually, and hold 21 patents. Solace counts blue chip customer base, or Solace counts many blue chip customers as base customers across many industries, right? We're extremely well established in financial services and telecommunications, solid references in gaming, government, transportation, manufacturing, and other verticals. So what is Solace, right? What do we do? Solace has an open data movement platform, right? And Solace with Hazelcast together is an applicable solution in many different domains, spanning big data, cloud IoT, and next-gen messaging, right? Providing capabilities like data collection, filtration, and ingestion, integrating with Hadoop tools like Flume, Spark Streaming, and Apex, providing portability of applications to all clouds and connectivity between clouds, support for private cloud technologies like Cloud Foundry or Bluemix and OpenStack, and available in public clouds as well, like AWS and Google Cloud. The ability to link IoT devices to data centers, supporting any data, anywhere, and any device. It's open and scalable with support for protocols like MQTT and other IoT technologies. And finally, it's support for multiple protocols and standards-based data movement, right? Messaging as the backbone for event-driven architecture rather than using orchestration via ESBs, which can be bottlenecked sometimes. Support for straight-through processing, omni-channel support, and facilitating providing faster response times for applications that leverage asynchronous transactions and caching. Solace dives deep into the enterprise. It connects all of the applications in real time and allows that data to be selectively streamed into a big data lake and or an in-memory grid of your choice, like Hazelcast. Solace is the data river to the data lake, if you will. Supporting, in this case, two specific scenarios. Streams of discrete events requiring potentially order maintenance from many sources to facilitate record-by-record processing. And B, the data fire hose. So it's the capture, the aggregation and capture of data into a data lake, depositing it there and enabling broader analytics batch processing, right? With key APIs being things like security, everything's highly secure, and operational excellence. I'd like to hand this over now to Viktor for a brief overview of Hazelcast.
Thanks, Mike. I really like your metaphor of diving into the river of data, and I think for today's topic is a great metaphor explaining, like, you in Solace, you responsible for moving data, for making data available faster across multiple heterogeneous, potentially, because we're running in a global environment where we don't know where what kind of latency we expect. And with Hazelcast, we're responsible for storing this data, make this data highly available, scalable. And one of our products that we're going to touch base today is Hazelcast in-memory data grid. So with in-memory data grid, users and developers and operational administrators, they can achieve application scalability with storing data in memory. So grid is your storage. So there's no need to have a disk. Data will be stored in memory in the network. So Hazelcast is a company, we started in 2008. Right now we're roughly around 75 people. The former people from Oracle Web, what was the name of this company? How come? Golden Gate. The people in Golden Gate, Spring Source, and Terracotta, IBM on our board. Former staff from all over the companies, different companies in data, open source, commercial, many other things. Hazelcast in-memory data grid was open source technology from very beginning, and the company Hazelcast is a commercial open source company. We're providing support, we're providing some commercial plugins, and we're providing support, training, and other commercial features. But in general, in-memory data grid is open source product. So where to use in-memory data? Where to use in-memory grid in this world, in this day? So first of all, when you need to break a latency with interaction with disk-based software, like databases, different big data tools, and there's a trend that more and more technologies are moving into in-memory compute world because memory becoming cheaper, memory becomes available, and to achieve like fast big data, you need to switch back from disk-based storage. And in this case, in-memory solutions become very handy. And for many use cases, including a real-time reaction, the in-memory grid is great choice for providing data. So situation awareness use cases and web scale, this is place where the in-memory grid, Hazelcast in-memory grid is shows all the bright colors. So the couple use cases where people usually using the in-memory grid these days. So I would like to talk when the people asking like what's the in-memory grid. I would like to say that the three things that you usually need to remember. So first of all, it is distributed storage. So it is distributed key value storage. You can think it as a distributed hash map. So once the data is loaded into this distributed storage, it would be wasteful to move data around in terms of like pulling the data somewhere and to do computation. So this is why Grid also provides capability to run distributed computation. And as additional plugin, we're providing built-in messaging for communication between components. So right now, these days, we've like this web scaling requirement and microservices architectures. In-memory grids are actually I find a very good fit in providing either also the data backbone for your microservices or providing means to scale different components of particular microservice. So when we talk about microservice, we're talking about one service that will be responsible for one particular feature. But it doesn't mean that this service needs to be just one process that runs there, because it's not safe. If this service will go down, potentially other services will not be able to receive the data. So using grids, it's a very good tool for building scalable microservices, and I will talk about this one a little bit in a couple more slides. Plus, when we're talking about web scaling, scaling data as web sessions, this is a very good fit for in-memory grid as well, because every time you go, for example, for Amazon and you're putting something into your shopping cart, and after a certain time, if one of the server would crash, you would be not super excited to see that your shopping cart is gone, because the session where this shopping cart was stored on this node or this application server that went down. So having the web session clustering capabilities is essential, and this is a huge win for many companies who use grids who use Hazelcast for that particular purpose. So as I already mentioned briefly, distributed data structures, key value storage, that enable the caching use case. Usually people thinking, okay, so if it's key value storage, it is a very good fit for caching use case. And apart from that, computing and distributed messaging, it's also a neat feature. For example, to perform like a very fast computation in memory, it will be faster to execute it in place instead of like moving data around. For microservices use case, another thing I think is very essential these days. It's provide a polyglot environment. So where it really doesn't matter which language developers are using to build these microservices. If it's Java or it's C#, C++, Python, Node.js, or Scala, we provide these abilities to and unified APIs that allows to interact with in-memory storage that provides scalability and data safety and resiliency, but stay in your like comfort zone in terms of programming language and programming tools. And I already mentioned that web session clustering these days, we're building more user-facing applications, and the data and from user interactions is growing. We're getting more and more users and enabling that come from different interfaces, including web interface, mobile interface, etc. So web clustering is is a key, and we're focusing on this use case in Hazelcast. There are a couple links that I want to share in terms of rise of in-memory data in general, and the Forrester and Gartner leading analytic agencies, they found that in-memory data grids and in-memory database right now is really very hot topic in terms of tech, and adoption is growing day by day. So when I talk about a memory grid, people usually asking, okay, so how you guys related yourself to database? So to speak, it's not essentially what we do. However, some of the aspects that we provide through the API, for example, key value storage, can fit Hazelcast in the NoSQL world. So that's why we can say, okay, so certain use cases that you might do with traditional NoSQL databases, you can also perform with Hazelcast. And apart from key value storage that provides very simple and very intuitive way how to interact with grid, we're also providing capabilities that you can find in traditional NoSQL databases. For example, ability to query data when you don't know the key, but you know certain parameters, certain properties of the value. So using a query language, SQL-like query language, ability to build in-memory indexes to speed up access to particular to speed up access to particular value or a particular field inside the data, makes in-memory grids also very good choice for replacing traditional NoSQL databases. And in this graph, I'm showing that the growth of DB Engine. DB Engines is a very popular website where you can see independent ranking of particular database technologies, and they use social media, they use surveys of engineers, developers, etc. And that's why many people also look Hazelcast and solutions like Hazelcast on DB ranking. So this is very important metrics for us to understand that the NoSQL use case and database or in-memory storage, scalable in-memory storage, is very essential. So Hazelcast was open source for day one, and this is why it allows Hazelcast to be integrated with many existing open source or commercial open source products, ETL tools like Talent, or agile process management like Jira, or the binary management system Artifactory from JFrog. They all use Hazelcast not only for in-memory data storage, but also as a driver that allows to scale their application. So Hazelcast is not invasive. Hazelcast doesn't require much of installation. Very easy to use, and this is why many companies and many open source projects integrate Hazelcast as part of their product to solve the problems of scalability and data distribution. So quickly, in this diagram, we usually show some of the features that we provide, some of the features that are available with open source platform and enterprise platform. So orange is open source technologies, and we, as a Hazelcast, we build a couple plugins on top of the open source core to solve certain needs of our customers. And the WAN replication feature that we're going to talk about today is one of these features that we represent as enterprise plugin. So as on the very beginning, I mentioned that Hazelcast is very easy to integrate. So this is why the embedded topology, where Hazelcast becomes the component of application, and instance of application becomes member of the cluster. So using the Hazelcast as a driver for scalability features in your application makes it easier to build scalable applications by itself. However, in more traditional way, Hazelcast also can be deployed in traditional cluster client mode, where multiple different clients using different languages and native APIs can access to this cluster. Also, sometimes these two topologies are merged, like hybrid type of topology, where in embedded mode, certain applications provide ability to connect through the client. We also support different type of microservices architectures, starting from transition from the monolith type of application into the microservice architecture, where Hazelcast behaves as the data backbone across multiple other microservices. Very popular, I guess, very popular use case for greenfield projects of microservices is to use Hazelcast not as the data backbone, but as the scalability tool that allows to write scalable microservices, like actual services that will use Hazelcast as the scalability tool. And the same thing is available throughout different clients. Once again, I wanna make it clear that these days staying in one particular technology stack will not go well. So this is why having like a polyglot API allows to different technologies to integrate. This is the way to go, because these days it's all about developer productivity, and developers tend to choose different technology for serving their need, because today it is simpler, it's cooler, and there are many other openings and opportunities on the market for different type of technology. So having ability to support languages like Python, Node.js, C#, and others will make the building microservices is it's not that painful as it might be a couple of years ago. So that's why it's so popular and it's easy to build. All right. So in terms of clouds, of course, cloud is a huge thing. And if you can think about the in-memory data doesn't require disk to have, and the cloud environment is very natural fit for in-memory technologies. And with Hazelcast, we support all sorts of clouds, including infrastructure as a service clouds like AWS or Azure, Cloud Foundry like PaaS, platform as a service, and we support native discovery, so the cluster members can discover using native API through Cloud Foundry or Kubernetes or any other thing. So an API to doing this is open. So I already mentioned that the polyglot ecosystems is very important for Hazelcast. If you're interested in this comparison, there is Hazelcast.org client languages. There is a table that shows like all available feature across all different clients. Okay, so I'll skip that so we can focus on the going global with WAN replication. All right, so one of the things that we do in Hazelcast is we build in memory grid and when we build in memory grid, the network speed and network latency becomes an essential, because you're storing data not only in one machine, you're storing data in the grid, you're storing data in network. So having fast network is important for fast data read and write. So this is why we not suggest to people to span the cluster across multiple geographically distributed regions, but to solve the problem when they need to have this ability to have multiple data nodes in multiple data centers, we provide the capability called WAN replication. So basically, typical use case, you have multiple data centers, one data center. I don't know, we tend to use this use case with London and Paris. In London, we have one data center, and in Paris, we have another data center. And we're synchronizing data between these two data centers one way, so we can have one like a active-passive mode where we have a hot backup cluster running, and in case of failure of main cluster, we can switch back to the backup cluster. Or it can be active-active when you have two applications that running with working with different sets of users in different regions, and because of this latency, you cannot send all the users to one cluster. So we use the WAN application to provide synchronization to this cluster, so both users in Paris and London will see same picture everywhere. What kind of data usually replicated, and what kind of data our clients usually replicate? So HTTP sessions. Once again, the web clustering and the clustering of the web data, it is our bread and butter. And with integration with different web servers, Java-based web servers, we know how to store the data, and with WAN application, we know how to distribute it across the wide area network. Also, any type of data that you store in Hazelcast cluster, like key value storage, can be distributed, can be different orders, counts, etc. And in this picture, you can see right now, it is just a one way. We have live cluster in London and disaster recovery cluster in Paris. However, with another use case, like when we lose in this use case, if we lose London, we will reroute our clients to use data from Paris. So this is pretty much how disaster recovery works with in-memory data. Now, with active users will work only with local sets of data and view their own things. However, they can access to data that will be asynchronously replicated from another cluster from another part of the world. Okay, so now when Mike talked about data movement and how we can jump into this river of data and move data from one place to another. So the essential part, for example, in this use case, it's not in the cluster in London or not in the cluster in Sydney, but what has actually happened in between. How this data going through all these like network hoops, maybe sometimes through some private networks, sometimes through the public networks, and the latency here might be high, or the channels, communication channels, might be not very stable or not very reliable. So how are we solving this problem with Hazelcast and Solace? Mike, do you want to talk about this a little quick?
I do, yes. Thank you, Victor. All right, so first of all, I want to start off, why Hazelcast with Solace, and Victor touched on that. The Solace Hazelcast joint solution, what it does is it enables a multi-cloud and a hybrid cloud replication of the Hazelcast clusters for worldwide operation, right? It enables this with enterprise-grade reliability, WAN scale out, and low latency cluster replication. Right? So by combining the Solace store and forward WAN messaging solution with Hazelcast, right, the organizations can reduce their WAN bandwidth costs. You can minimize the data update propagation time and insulate the infrastructure from network or data center outages. This solution is ideal for companies who need real-time data to be current across diverse geographical areas as data values change, right? So example scenarios might be financial institutions that synchronize real-time position books, or risk data across global financial centers, maybe mobile carriers that need customer or operational data in memory to provide a fast and seamless end user experience. So why together? That's why, and that's what we provide. How is this provided, right? So let's talk a little bit about what Solace brings to this effort here. Solace provides the optimized WAN synchronization by leveraging its WAN messaging features, supporting things like bidirectional streaming, fan out at the edge, and real-time compression, both of those latter ones reducing network utilization, right, and improving efficiencies there. All Solace message router appliances have integrated WAN optimization features that you typically would find only in dedicated WAN optimization products. So specific features include things like the use of parallel TCP connections, streaming compression that typically yields 80% payload compression, control over buffer levels, and TCP parameters like slow start and congestion management, right? And all of this with a granular and detailed real-time data path statistics that are captured for troubleshooting and capacity planning. These are always on in development or production without affecting the performance of the solution. Oops, sorry guys, I want to. All right, store and forward replication is designed to reduce the communication over slow WAN links. So an update replicates first to a nearby Hazelcast, in this case Data Center 1, and the replicas there. And from there, it is propagated to Hazelcast clusters that are further away. Store and forward replication eliminates the need to send every change directly from the server that's accepting the change to other servers that hold replicas of the affected directory partition. A server that's accepting a change can send the change to a nearby server. One of these servers can then send that change to a distant server, and so on and so forth, right? So store and forward can greatly reduce the WAN traffic that's produced during replication. In scenarios like this, lab tests have shown end-to-end Solace performance being 10 times greater than that of competing messaging solutions, right? And all the data transfer we're talking about is done securely. Solace supports comprehensive authentication, authorization, and encryption features that ensure the infrastructure and information are protected at all times, and that you can pass both internal and regulatory security audits. Solace integrates with Hazelcast nodes in memory cluster to provide also a distributed, right, and decoupled publish and subscribe backbone for fan out, right? And it's as well optimized for efficient WAN synchronization. So as the data changes in a local Hazelcast node, an event's published once to the Solace fabric, right? And this is immediately fanned out to other nodes in the distributed cluster, right? Solace leverages the advanced compression, the TCP protocol optimizations, and in this case, routing optimizations to maximize the data throughput and minimize the latency over the WAN. Looking at global WAN messaging performance, compared to other software messaging providers, Solace can be as much as 30 times faster at WAN replication, right, which allows Solace to push more data over smaller pipes, providing this performance with lossless levels of quality of service, even through spotty networks and publisher isolation. Down below, we can see in both Trans-America and Trans-Pacific scenarios with 70 millisecond and 175 millisecond round-trip latencies, respectively, and 155 megabit per second capacities for those pipes. As the packet loss ratio increases, the advantage to using Solace for throughput is maintained, and in some cases, it actually increases, right? Again, kind of highlighting the WAN optimization and the TCP optimizations that we have to provide that level of performance and that quality of service. An interesting capability as well is leveraging Solace as a shock absorber, right? Handling WAN issues that for outages and for burst handling, right? Burst publishers. Solace message routers, they don't let slow consumers impact the performance of publishers and fast consumers, so they're isolated there. Solace message router appliances have been specifically designed to handle those slow consumers, right? I'll activate to handle slow consumers in such a way that they don't impact the performance of the publishers on the back end, right? So for guaranteed messaging, publishers and fast consumers are identified and they're prioritized over slow or recovering consumers, right? Even as the message storage begins to climb, right, and the slow consumers continue to increase. And then as these slow consumers come back online, right, or the network connections come back up, all that persisted data can then be fed to what was the slow consumer at an increased rate, all the while still not pushing back on publishers and not affecting the ability to deliver to the existing consumers in the solution. So again, complete slow consumer and publisher isolation there. We have, in conjunction with Hazelcast, Solace and Hazelcast have a joint white paper that can be accessed from the link on this page. It goes into a lot more detail around some of the use cases that were mentioned today in the webinar, things like store and forward and WAN optimization. You can learn more about how the scenarios were built, and then the specifics around the test.
Yeah, I think we have a couple more minutes. We can talk a little bit about this, like how we tested and what we tested. Dave, how are we on time?
I think you're right, Viktor. I think we do have a few more minutes here, which is good.
Yeah.
Did you want to say a few things, Viktor, and then I'll comment as well?
Yeah. Yes. Yeah.
Right. Sorry, so I was scrambling for the mute button. Yes, you have plenty of time.
Yes. So as Mike mentioned on some of the use cases, including slow consumers and burst of the data, we actually tested these use cases with Hazelcast features called cluster sync. So we essentially have this ability to, we have a cluster that's already hot and the data is already there, and a couple gigabytes of data is already in memory in one cluster, and we just need to send this data across the WAN as soon as possible. And this is why we use this API that's available through the REST, or we use just through the REST that tell Hazelcast push it, but it's also available through the management center. So in this case, we can simulate this burst type of use case when data is ready to be pushed almost like immediately. And this use case is explained in this white paper. You can find a screenshot that demonstrate what was amount of data and what kind of system we tested on. So handling a slow consumer allowed that prevent the incoming part, the part that will be reading data, not be overflown by or not be overwhelmed through this incoming event. And having Solace, we were able to provide kind of similar to a back pressure mechanism. So in this case, we have the fast producer and slow consumer, and the consumer can behave with the same speed. The Solace can provide like same speed as the consumer can handle this data without overwhelming or overflowing this consumer with all this data. The same thing with producer, because sometimes when application intensively write data into the target producing cluster, local queues might not be able to handle all this load. Potential it's configurable, and the sizes also can be set, but in very high load applications, some of the messages might be lost. With the Solace solution, we didn't see any loss of data, which is good, which is exactly what many people are required. Plus, having some intermediate solution that provides ability to handle actual WAN outages. So when there's like cable broke down or something like that, the Solace can accumulate the data, and data will not be lost. And once the network will be restored, you can, similar behavior when you have a burst. Like the Solace will start pushing data in a speed that maximum available on this particular network. And this is another kind of thing. It's a kind of bonus feature, right? When the Solace is able to allocate all possible bandwidth to provide optimized data flow. And as Mike already mentioned in this white paper, we're gonna send this link after. You can see like in what use cases this is like good solution, plus all this nitty-gritty numbers and different pieces of what exactly was tested is there.
Thanks, Viktor. Yeah, so I wanted to add, you covered the test very, very well. Just points to kind of remember there. As Hazelcast, as you can see in the document when you pull it down, as fast as Hazelcast could produce the data, Solace could replicate that, and that's demonstrated. There's performance graphs that are part of the white paper that demonstrate as fast as the messages were produced, they were consumed by the receiver on the destination side. Again, the capacity to leverage the WAN connection as efficiently as possible is demonstrated there. And as mentioned by Viktor, at one point in time, the WAN was brought down, right? So the WAN was completely turned off, and the Hazelcast publishers still have the ability to publish data. Right, they're completely abstracted from the fact that the WAN connectivity is down. They can continue functioning just as they normally would. Solace then owns that the delivery of that data, and then when the WAN connection came back up, that message spool was drained, and then of course it went back to providing that real-time data synchronization. So the details for that are in the white paper to take a look at those performance capabilities, and again that slow consumer capability. Thanks, and with that, I'll hand it back over to Dave for closing remarks and questions if there are any.
Thanks, Viktor and Mike. That was great. It's a fascinating view into making sure this data is available and fast. Looks pretty straightforward to implement, and I suspect members in our audience are already facing this widespread WAN problem. So this is your last chance to get questions in. You can type them into the questions box on your webinar screens here. Also, if you would, please remember that there are attachments available in the attachments tab below. And if you could, give us a rating in the Rate This tab also below. This webinar will be available for as pre-recorded video. And I'm not seeing any questions coming in, so I'm sitting here looking forward to this.
I have one question. I guess Mike can address it. That do I need to have hardware, or I can use a cloud appliance for doing the same stuff with Solace and Hazelcast?
You can use either one. There are a few performance capabilities, not all of the ones that I mentioned, but there are a couple performance capabilities that are part of the physical appliance because the specific firmware resides on hardware. So there are a few pieces where you won't see quite the performance gain from the software solution, but you absolutely can perform the capabilities with either solution. The tests that were performed, just real quick, the tests in the white paper were done using the hardware.
Yes.
But the software
we use the hardware environment, but I just want to make it clear that and Hazelcast and Solace they provide integration with cloud. If you in cloud these days, these solutions are available through the data replication across cloud regions, not only like WAN as you have a data center, but also within cloud regions. Very similar approach. Obviously, because of all this virtualization with this cloud how do you call it? Different limitations that different cloud providers provide. You obviously will not achieve the same performance as a hardware appliance. However, this option, if it's required to you to run this in cloud, its option is also available at your disposal.
Yeah, very good point, Victor. And it's worth noting as well that the steps that you would go through, the management, the deployment, the setup configuration, everything is exactly the same, regardless of the physical or software appliance. So once the appliance is deployed, all the setup and functional capabilities are exactly the same.
And I'd like to add that if anybody wants to play around with the virtual message router, VMR piece in here, there's a free community edition version out available on our downloads website. So feel free to download it, kick the tires, and find out what the message router is capable of doing. And it's also a fully functional download as well.